So today we'll be looking at the periodic properties. We'll be looking at the periodic table and properties on the periodic table. We'll be looking at properties such as atomic radius, ionization energy, electron affinity, electronegativity, and ionic radius. Before we get into these individual trends, let's look at the periodic table first. So the periodic table is made up of groups. We have a group here, group 1, group 2, 3, 4, 5, right? And right away, all the way to 18. Some periodic table is written as 1A, 2A, 3A, 4A. So we have periodic table looking at this. So groups coming down and periods go across. This is period 1, period 2, period 3. So if we look at any individual groups, we realize that the periodic table in general is made up of atoms are arranged with similar properties, similar physical and chemical properties. So if we take a look at elements in group 1. So if all these elements in group 1, except for hydrogen, they are all metals, alkaline metals. So hydrogen is also in group 1 here, and it's classified as group 1 because they all have one electron in the valence shell. The valence shell is the last occupied shell. So here we have our nucleus and our first shell, and this has one electron. So this represents hydrogen. Below hydrogen, that's be lithium, we have the first shell has two electrons, and the last valence shell also has one electron. So this valence shell has one electron, this valence shell has one electron as well. If we were to look at the element that comes below, sodium valence shell also has one electron. So elements in the same group will tend to have the same number of electrons in the valence shell. So that would kind of explain some chemical properties, similar chemical properties and physical properties. So as we go across, we're adding one more electron. So hydrogen, the next element go across is 2, that's helium. So here we have 2 electrons in the first shell. And the next one will be 3, then 4. So here the first shell is maxed out at 2. So our next electron, we have to put it in our second shell, and here this also has 2. So here in group 2, we have 2 electrons, 2 electrons in the valence shell, 2 electrons here. So as we go across the elements in the periodic table, they one as the number of protons increase, we add electrons. This has 1 proton, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's how we introduce our elements, and if the atom is neutral, the same amount of protons would mean the same amount of electrons. So if we were to move one more over, we would see we'd have 3, because the second shell is able to have 3 electrons, have as much as 8. So we can do 3, the next one will have 4, 5, 6, 7, 8. All right. So now that we understand it, let's try to understand now. Now we're trying to figure out what are some how does this electron arrangement influence properties. So first, electrons are added one at a time, moving from left to right across the period. As this occurs, the electrons in the outermost shell, that's the valence shell, experience increasingly strong nuclear attraction, right? So the electrons become closer to the nucleus and more tightly bound. So as we go across, we're adding electrons to the same shell, and we're also adding protons. So this increases the nuclear charge. As we go across, the nuclear charge is pulling on the valence electrons more and more. So this is experiencing a pull. This one experience a greater pull because we have more protons here, and we have one more protons here, so we're experiencing a greater pull. So as we go across, the size of the atom here will decrease. So going across, we understand the size of the atom will decrease. But what happens as we're going down? As we move down a column in the periodic table, the outermost electrons become less tightly bound to the nucleus. This happens because the number of filled energy shell start to screening the outer ones, and it becomes easier to remove these electrons. So as we go down, we're adding electrons to new shells. So this is going to be much larger. This coming down is going to be much larger because these electrons are added further away. And as they had further away, the effect the nucleus would have on these outer electrons would decrease because the inner ones would screen the effect because these are stable. These filled ones are stable to screen this effect. So let's look at atomic radius. So as we're moving from left to right across the period, let's look at this diagram here. So as we move from left to right, electrons are added one at a time to the outer shell. The electrons within a shell cannot shield each other from the attraction to protons. Since the number of protons is also increasing, the effective nuclear charge increases across a period. This causes the atomic radius to decrease. So as we go across, the atomic radius decreases. And going down, we're adding electrons to new shells, so the atomic radius will increase. Ionization energy. Here we're seeing ionization increases as we move from left to right, and ionization energy increases as we move from the bottom to the top. So what is ionization energy? Ionization energy is the energy required to remove an electron from a gaseous atom or ion completely. The closer and more tightly bound an electron is to the nucleus, the more difficult it is to be removed. Right? So you would expect the ionization energy to go in the opposite direction to atomic radius, because these are going across here, the atomic radius is decreasing, so these electrons are going to be held tighter, and coming down, the atoms are getting larger, so ionization energy would increase in the opposite direction. The smaller ones will have a higher ionization energy. What about electron affinity? Well, electron affinity reflects the ability of an atom to accept an electron electron affinity is kind of somewhat opposite to ionization energy. So electron affinity reflects the ability of an atom to accept an electron. It is the energy change that occurs when an electron is added to a gaseous atom. Atoms with stronger effective nuclear charge have greater electron affinity. Right? What about electronegativity? Electronegativity is a measure of the attraction of an atom for the electrons in a chemical bond. So when we talk about electronegativity, we have to think about it's in a bond. So we're this is if you're sharing, if you have a bond between hydrogen and say fluorine, electronegativity is a measure of the attraction of this atom in a chemical bond. So this has a greater electronegativity because the electrons are not going to be shared equally here. Most of the electrons are going to be pulled towards the fluorine. The fluorine has a greater electronegativity. It pulls most of the electrons toward itself than the hydrogen. In fact, fluorine is the most electronegative element in the periodic table. So electronegativity increases as we go up and it increases as we go across. So you'll see around here, fluorine would have the highest electronegativity value. Hope this helps.